Okay, so in the last little video we looked at ions, and the reason we did that is so that we can talk about ionic compounds. Okay, so we get ionic compounds when we get a positive metal ion and a negative non-metal ion joining together. Okay, and these are called ionic compounds. We've sort of almost looked at these a little bit before when we started looking at the formula for compounds, and we were looking at how many atoms and what type of atoms were in a compound. And we saw from some of them that we have a ratio. So we've looked at CO2, carbon dioxide. Okay, and remember we said that we've got one carbon atom to every 2 oxygen atoms. And now we're going to have a look for some of these at why that might be. Okay, so we're going to start off with an example from your book. So if we look at 2 elements that are in our top 20 that we can have a look at, we're going to look first at Ca, which is calcium. Okay. Now if you have a look on your periodic table, you'll know that calcium has got 20 electrons. So if we were going to write its electron arrangement, we would have 2 in the first shell, 8 in the second, we would have 8 in the third, so that gives us 16, 17, 18, and we would have to have 2 in the last shell. And if you look on your periodic table, it is in group 2. So because it's in group 2 and calcium is on the the left hand side of your periodic table, we know that it's a metal. Okay, now if we know that it's a metal, it's going to have a positive ion. And because it's in group 2, it's going to be a 2 positive ion. So when we write calcium's ion, it's going to be 2 positive. It doesn't matter if you write the positive first or the 2 first. It doesn't actually matter at this stage. So there is our calcium ion. Now another one that we're going to look at this time is over on the right hand side of the periodic table, and this is a non-metal. And our non-metal that we're going to look at is chlorine. Okay, so if you have a look for chlorine. Okay, now chlorine, if you have a look, has got 17 electrons. So if we were going to write its electron arrangement, 2, 8 and 7. Okay. So if we have a look at where it is in the periodic table, this one is in group 7. It's a non-metal, so it's going to be a negative ion. Now this is where you have to be careful, because it's not going to be 7 negative, but because it's the first group in from our inert gases, there's going to be a 1 negative charge. So this one will be Cl negative. Okay, so we've got a 2 plus charge on our calcium, and we've got a 1 negative on our chlorine. Now what we have to do with this is try to balance the number of charges on each side, or the amount of charge. Okay, it's a little bit like when you probably have played with magnets before. Okay, we need to get these 2 things working so that they're attracting each other. So opposite charges will attract, negative and positive. Okay, and so we need to have a balance of the same amount of negative charge as we've got positive charge. So because we've got a 2 positive charge, we need 2 lots of negative charge as well. So when we write the formula for this thing, so if we were going to join these 2 things together, so calcium chloride, we would have 1 calcium, but we would have to have 2 lots of this. So we would say Cl 2. And that's where those little numbers came in that we looked at before. So basically calcium, because it's positive, and we need 2 chlorines because they've only got a negative charge, and we need 2. So this gives us our formula, and it also tells us the ratio now that these things are in, and that has got to do with the charge on these ions. If we were going to say, well, what is this compound called? The calcium doesn't change its name because it's a metal, but because we've changed the chlorine into an ion and it's a non-metal, it does change its name. So instead of being chlorine, it becomes chloride. So we have calcium chloride. Okay, so it slightly changes its name when it's part of a compound. So we can tell the ratio of things in a compound just by looking at the formula, and that can sometimes help us to work out what the ions are as well. So if we were going to look at an example, I'll just let's write this off for a moment. If we were going to look at an example like this one, which is in your books, okay, we can see that we've got magnesium and bromine here. Okay, and if you have a look at those on your periodic table, you'll find that this is a metal and a non-metal again. So we know we've got 1 lot of magnesium and we've got 2 lots of bromine, or because it's in a compound now, it'll be bromide, so it'll be magnesium bromide. Okay, so we've got 2 of those. Now if we look at where magnesium is on our periodic table, it's in group 2 and it's a metal, so we know that the charge on our magnesium ion will be 2+. Now if we look for bromine, we can see that it is in group 7, so it's going to have a -1 charge on, which makes sense now if we look at this, because we need 2 negatives to balance our 2 positives up here. Okay, and there are some more examples of that, and those in your notes.